I'm going to quickly run through the answers to the questions that we did before half term. Okay, now I'll do the first few of these relatively quickly. If you need to pause it or go back through them, just do so. All right, so this is the first question. So we can see that on the reactants, we've got one molecule of hydrogen and one molecule of chlorine. And then on the product side, we've got two molecules of HCl. Now I know before half term I did this thing where I wrote the energies on top of each bond. I'm not going to do that. You can do that if you want, that's perfectly fine. Any question you get like this, they give you loads of space, so feel free to use up loads of space, write in the bond energies like that. I'm going to do it slightly differently this time. So underneath, I'm going to write how many of each type of bond I've got. So over here I've got one HH bond and one Cl-Cl bond. Okay, and the HH bond, if I look on my table, is 436. So that's going to be 1 times 436. And my Cl bond is 243. So I've got 1 times 243. So 1 times 436 is 436. And 1 times 243 is 243. So if I add those up together, that gives me 679. And then on the product side, I've got 2 times HCl, which is 2 times HCl is 432. 2 times 432, which is 864. So then I do this number minus this number. So I do 679 minus 864. Use my calculator for that one. So 679 minus 864 gives me minus 185. Minus 185 kilojoules per mole. Okay, so it's exothermic because it's a negative sign, which means we're releasing energy to the surroundings. Okay, so on to the next one. Okay, so now we've got hydrogen plus oxygen gives us water. So same again. I've got 2 hydrogens. I've got 1 oxygen. Remember, oxygen's a double bond. And on my products, I've got HOH, that's 1 water, and that's 2 waters. And same again, I'm not going to write the energies above the bonds, but you can do that if you want. I'm going to write down here, well, I've got 2 times HH, 1 times O, and over here I've got 1, 2, 3, 4, 4 times HO. So HH is, looking at my tables, 2 times 4, 3, 6. OO is 1 times 498, and my HO bond is 464, so 4 times 464. So 2 times 436 is 872. That's 498. If I add those up, I get 71370. And 4 times 464, I don't have to use my calculator for that. 4 times 464 is 1856. And then I do this number minus this number, 1370 minus 1856, and I get minus 486 kilojoules per mole. Again, exothermic, larger, more energy released than the last one. But yeah, so both of those quite straightforward. If at this point you're watching this and you're thinking, I've got no idea what he's talking about, you need to go back and you need to watch the video from before half term where I explain what this whole process is. Okay, you should really be able to follow this. If you can't follow this, you need to go back and watch the previous lessons video. Okay, on to question C. Okay, so we've got the combustion of methane. So it's methane plus oxygen combusts to give us carbon dioxide and water. So I'm going to predict that this is going to be an exothermic reaction. It's going to be, so methane, that's what comes out of the gas tap in the lab. All right, so I think there's going to be quite a large negative number because it's going to give out quite a lot of energy. So methane looks like this. And I've got my 2 oxygen molecules. Now, in the questions down here, it is 2 oxygens, but on the form that I put on the, so that where you submitted the answers, it wasn't balanced. So it was only 1 oxygen. So you might have made a mistake there, although you should have been able to notice that because none of the answers would have been right doing it that way. But anyway, let's carry on. So my products are carbon dioxide and 2 waters. Okay, don't worry if I'm going too fast. If it's too fast for you, just pause it, rewind it, watch it again, look at the diagrams. Okay, so I've got 1, 2, 3, 4, 4 times CH, and I've got 2 times O double bond O. And I've got 2 times C double bond O, and I've got 1, 2, 3, 4, 4 times OH. All right, so 4 times CH. CH is, looking at my table, 4, 1, 3. Oxygen is same as before, 4, 9, 8. C double bond O, if I look now, C double bond O is 805. It's not 358. 358 is C single bond O, which we'll use later. C double bond O is 805. It's a stronger bond, larger energy. So that's 2 times 805. And OH is 4 times 4, 6, 4. So 4 times 4, 1, 3 is going to be 1, 6, and 4 13s are 52. 2 times 4, 9, 8 is going to be 9, 9, 6. If I add those up, 2 and 6 is 8, 9 and 5 is 4, 6 and 9 is 17, 1 is 18, 2, 8, 4, 8. Is that right? I don't think that's right. 2 and 6 is 8, 5 and 9 is 14, 1. I'll just get my calculator. All right. 1652 plus 996. Do 6 for it. How did I get that wrong? 2, 6, 4, 8. All right, so always check your maths. 2 times 805 is 1610. And 4 times 464 is, well, we did that up here. So that's 1856. 1856. 6, 6, 3. Right. So if I do 2, 6, 4, 8 minus 3, 4, 6, 6. 2, 6, 4. This I have to use my calculator for. 3, 4, 6, 6 is minus 818 kilojoules per volt. So it was a large negative number, as I thought it would be. All right. Okay, moving on to the next one, we have the combustion of propane. So this is propane, C3H8, combusting it with oxygen to make carbon dioxide and water. So again, combustion, I think this is going to be a negative number because it's exothermic. I expect it to be larger than methane. It's going to release more energy than methane did. So if we draw these out, again, if you weren't sure what these looked like, I showed you the structures at the end of the last video. So if you weren't sure what they were, you needed to watch the last video. All right, so I've got all drawn out. Quite a lot going on now. So let's have a look. Over here I've got 2 carbon-carbon double bond, single bonds, 2 times C. I've got 1, 2, 3, 4, 5, 6, 7, 8. 8 times CH. So this is where you need to be really careful that you don't miss any bonds. So now it might be useful for you to write the numbers above the bonds, just any way that you can make absolute sure that you're not missing anything out. And I've got 5 times OO. Over here I've got 1, 2, 3, 4, 5, 6. 6 times CO. And I've got 1, 2, 3, 4, 5, 6, 7, 8. 8 times HO. Right. So now I'm using the single bond. So now it's single, C, single bond, 3, 4, 7. 2 times 3, 4, 7. 8 times 4, 1, 3. 5 times 4, 9, 8. And over here I've got 6 times 805 and 8 times 4, 6, 4. And calculator to work all these out. So 2 times 347 is 694. 8 times 413 is 3304. 5 times 498 is 2490. 6 times 805 is 4830. And 8 times 464, 3712. Now if I add those up, what do I get? 8542, and over here I get 6488. So I do 6488 minus 8542. Remember, it's always this number minus this number, and I get minus 2054 kilojoules per mole. Yes, it is a large negative number, larger than before. All right, so there were a few wrong answers for this one. So some people chose plus 2217 kilojoules per mole, and some people chose minus 2748 kilojoules per mole. Okay, now if that was you, that would be because, so for this one, it would be, if you did get this number, it's because you had, instead of 6 CO double bonds, you had 3 times CO. So you just looked at this and thought, oh, well, look, that's got a C double bond O in it, and there's 3 of them, so there's 3 CO double bonds O, but actually there's 2 in each one, so there's 6 overall, and you made the same mistake for 4 times HO, where there are 4 water molecules, but each water molecule has 2 HO bonds, so there are 8 HO bonds. Okay, and if you got this number, you forgot to add in the carbon-carbon single bonds. That's what you missed there. So you hadn't got this number here. All right. Okay, on to the next one. All right, so E, I've just drawn the structures out straight away. So we can see that we've got 1 times CC double bond, 4 times CH single bond, and 1 times HH. And then on the product side, I've got 1 times CC and 6 times CH. So this is my carbon-carbon double bond. So up here I had a carbon-carbon single bond, which is 347, whereas now I've got a carbon-carbon double bond, which is 612. So 1 times 612, 4 times 413, and 1 times 436. So that's 612. That's 1652, that's 436. And over here, my single bond is 1 times 347. That's 6 times 413. That's 347. And then 6 times 413 is 2478. If I add those up, I get 2825. And over here I get 2700. All right, so now if I do 2700 minus 2825, I get minus 125 kilojoules per mole. And there was a common incorrect answer for this one, which was minus 390 kilojoules per mole. And if you worked out and you got this value, the mistake you made was that here you didn't use 1 times 612, you accidentally used 347, which is the single bond. So you didn't differentiate between the the carbon-carbon double bond and the carbon-carbon single bond. So you need to be really careful with that. Okay, and on to the last one. Okay, so here we've got 1 times CC, 1, 2, 3, 4, 5, 5 times CH. I've got a carbon-oxygen bond, 1 times CO, and an oxygen-hydrogen bond, 1 times OH. If I write all those out, I get 1 times 347, 5 times 413, 1 times 358, and 1 times 464. So that's 347. 5 times 413 is 2065. That's 358. That's 464. If I add those up, I get 3, 2, 3, 4. Okay, and then over here I've got 1 times CC double, 4 times CH, and 2 times HO. So my double bond is 1 times 612, that's 612. This is 4 times 413 is 1652, and this is 2 times 464, which is 928. And if I add those up, I get 3192. And if I do 3234 minus 3192, I get 3234 minus 3192 plus 42 kilojoules per mole. Endothermic. Absorbs energy from the surroundings. Now, there were 2 common mistakes for this one. There was plus 307 kilojoules per mole and minus 307 kilojoules per mole. Okay, now hopefully you didn't just guess these if you chose these ones. You didn't think, oh, well, I don't like the look of that number, so I'm going to choose one of these numbers. Hopefully that wasn't you. The mistake you would have made here is, again, instead of 612, you used 347. So if you did that, you know, so if you had 347, 1652, 928, that would give you 2927, and then 3234 minus 2927 is plus 307 kilojoules per mole. If you got minus 307, it's because you did it the other way around. Maybe you didn't like the look of a positive number, so you did it the other way around to get a negative number. Don't do that. A positive number is fine. All right. So, like I said, if that was quick for you, or if you're not sure about anything, pause it, rewind it, watch it again, and if you have any questions, let me know. All right. But you need to be really confident with this process. Okay. It's really, really important. All right. Good work.